Okay, Ronnie, Sam. Doo-doo-doo. Hey, Ronnie. I just invited you for the live broadcast, and this is actually recording right now. So, did you get the invitation thingy? It's Google on Air. Cause I sent it to you and Sam. Do you see it? Do you see the request? Okay. Sweet. There you are. And there's Sam. All right. We got a live broadcast. Woohoo! I'm excited.
Guess we finally figured out how to do it.
I know, right? It took forever.
You figured out how to do it, because I have no idea what to do.
Well, remember that young lady that's in the class with us? Like, I saw her at the library, and we're going to start meeting on Fridays. And I asked her about how to do this, and I wrote notes on how to do this broadcast.
Gotcha.
Okay. So, I'm sorry you're not feeling too great, Sam.
It's all good. It happens.
Yeah. Okay, so did y'all already do the group preparation?
Yeah.
Yep.
Okay. I noticed a lot of it was the same of what we did last week, right? The standard deviation.
It said in the textbook reading stuff that it's all just review.
There's only a couple of new formulas that we had to do, if I remember correctly. But I tried doing the homework, and I didn't do so hot on the homework. What about you guys?
I haven't started it.
Yeah, I haven't either.
Okay. There's also this thing that we're supposed to do for our preparation. Do you see what this? It's like you're supposed to cut this out. Like, obviously, I haven't cut it out quite yet. But we're supposed to cut it out, and we're supposed to have like a random number sort of thing going on. For our group meeting tonight.
You can also just do it on a link.
Oh yeah, you can do the link too. I've got like a bajillion stuff open. Do you want to go ahead and do the link, Ronnie, or do you already have it open?
I'll have to open it.
Okay. If you could open it, that'd be fantastic. Oh no.
Sorry, my computer's taking a little longer.
Nope, you're fine. You're totally fine. It's so quiet here compared to last week. Last week all the kids were just like screaming. Okay.
Okay.
You got those random numbers?
I'm working on it.
Okay.
It's 1 through 30 and I need 5. Okay, so our numbers are 23, 9, 12, 28, and 27.
20, 30, 9, 12, 28, and what was the other one?
Okay, the first number is 23,
Oh, okay.
and then 9, 12, 28, and 27.
Okay. Got that taken care of. Um, so what is the mean of your sample? 12?
No,
Or would that be the median?
that'd be the median. I'll find out the mean. Hang on one sec. I'll get my calculator.
Okay. I found out that the hybrid class is very similar to our class too. Like it's not much different.
I know a couple of people that failed like the on-campus class
Why?
and passed, just didn't understand it and the teacher wasn't helpful. And then they took it online and passed it really easily.
Oh, wow. Okay, so the mean is 19.8.
No, you have to, because you're supposed to take the mean of the salaries that are in the boxes that are,
The mean in the boxes.
yeah, so you use the salaries from the squares.
Yeah.
Yeah, the numbers, the random numbers we got were the ones that you choose the random, so the random squares is what it is. The random salary.
Okay, let me write those down in the chat.
The mean should be, if I did it right, 48,040.
Okay. 3, 2. Are your roommates asleep, Sam? Is that why you're using the chat box a lot?
No, my throat just hurts.
Oh, okay.
Yeah, it's 48,040.
Okay. So this graph illustrates the sampling distribution of the sample mean. There's 142,506 people combinations of the 30 salaries, drawn 5 at a time. This graph represents the distributions of all the possible samples. Make a mark on the horizontal axis to indicate the value of your sample mean from part A. I'm not quite sure what they mean by make a mark.
That's because I looked at it and I wasn't sure either because you can't really make a mark on there.
Sam, do you have any idea? Oh, okay. We can use the chat if your voice hurts, or your throat hurts. That's fine. Okay. Maybe we can come back to that one. Does your sample mean appear to be unusual? Explain why you think it is or not unusual.
And I didn't really understand how to tell if it was usual or unusual. Oh, come. Chloe. She's on the other side of the fence again. Do you know what it means for it to be usual or unusual? Either of you guys?
Yeah, I'm gonna try and open up the textbook and see if that has anything to do with it. Like I'm thinking it's talking about like normal and like not normal distributions. That's how I'm interpreting it.
Well, it says the sample mean.
Just guessing, but I would say it's normal. Or usual, or whatever. Well, if you just... means are an average of something, and so if you look at most of the numbers, and most of the numbers are averaging at above like what your median is, then your mean would be above that as well. So I don't know, based off the numbers at least, I would say that it's usual, not unusual, but I could be completely wrong.
Well, unusual is right skewed, isn't it? That's what I was reading from the book.
Where did you read that at?
It's in my notes. It's from, oh, is it normal? When is the, let's see. Let me see if I can screen share.
Normal. Well, in one of the questions it asks in the like preparation homework assignments was what was the shape of the distribution of the sample mean, and it gives 3 different like guesses, and it's skewed right, skewed left, or normal. So I'm assuming normal does not mean it's skewed right or skewed left. My guess is maybe that it has that bell curve to it.
Well, a not normal one, an unusual one, is right skewed.
I don't know.
I'm not sure either.
Because just going off the homework assignment, I'm in the... Oh gosh, which lesson is this? I'm in the lesson 6 homework answer key. I'm looking at problem 6.
On the lesson 6?
Yeah.
On the homework?
Yeah. And it's saying that there's either right, left, or normal. And so normal, then my assumption based off of that is it's not left and it's not right. And so the only thing that leaves is that it just produces the normal bell curve, but I could be understanding it incorrectly. I'm not really sure. I had a hard time kind of understanding the homework this week.
Yeah, me too.
But I don't know, we get to do retakes on the homework assignments if we do them before Friday. So I kind of feel like we should just jump into the assignments and help each other out and try and get those done. And then from there, like, we can figure out which ones we did wrong and maybe, like, meet up again on, like, Friday night or something for, like, 20 minutes and just go over the problems that we got wrong and see if we can help each other then.
Okay,
I won't be here Friday.
okay. Are you usually working on Fridays, Ronnie?
Yeah, I work every day,
Okay.
so
Okay, why don't we just go ahead and start doing the homework assignment for lesson 6?
Okay.
the group meeting homework.
No, the homework.
Okay.
And then we can do do you want to do the group meeting homework as well, or do you want to do the homework right now?
It's up to you guys.
I don't care. We can do one. We can do both. We have to, no matter what, do the group meeting ones, though, because we're supposed to do those together.
Okay.
I want to just do
Why
the
don't
group
we-
meeting one.
Sounds
Okay.
good.
So the group meeting one.
Yeah. For lesson 6.
When using the when using the when taking samples of sample 5, what was the shape of distribution of means histogram when the parent population is right skewed?
This is in the reading somewhere.
Huh? Yeah, it's in the reading because I remember taking notes on it. It's actually Brother Renee went over this in his videos, and he said if it's not normal, the shape of the distribution of the mean is not normal. Right skewed, it's basically less than 30. So when it's less than 30, then it's right skewed. When it's more than 30, then it's normal, I want to say. Regardless of distribution of the population, if the sample size is large, the shape of the distribution is normal. And so, yeah, the sample has to be more than 30 for it to be normal.
Okay, and then right here it says, if the parent population is almost normal, then a sample of size 5 will probably be sufficient to assure that X will be approximately normally distributed.
Okay, so is it saying that it's right skewed? Am I understanding that incorrectly?
I have no idea.
Uniform before. Hang on a second. I'm reading something about it.
Okay.
Then next you go to the right. I have so many tabs on my computer open right now.
I have so many documents and tabs open too, it's unreal.
Okay. Freaking A, I hate statistics.
It's terrible.
Okay, let me go back to this for a second. I don't have a clue. It just downloaded itself on my computer. Holy Moses.
Like, I feel like it doesn't really go into this.
Measuring of number distribution is displayed by topic on the screen.
Why don't you feel like it goes into it, Ronnie?
I just don't remember reading anything about, like, right or left skewed. I remember reading skewed, but I don't remember like, I've only read, like, heavily skewed or something like that. Moderately skewed, so I don't know.
Mm-hmm. I think it's talking about, do you see my notes there, Ronnie?
Yes, but they're small.
Oh.
I don't know how to make it bigger.
Okay.
Let's see. How about now?
Yeah, that works.
Okay.
Where did you find this?
This is what Brother Renee was going over in his videos.
How do you get a hold of those things?
They're in the Q&A section of the course.
Oh, okay.
So, yeah, they don't take very long to go through. He only spends about 8 to 10 minutes or something.
He goes through in some of his videos and does the homework in them.
Does he?
Yeah.
Because the videos that I saw, like, he didn't have anything going on this time around. It was just, he was just talking about these extra notes.
Okay, repeat looking at the sample distribution for this population. Okay, I can't really find anything too descriptive on it. It's just really frustrating. I want to say normal.
It's kind of what I want to say, too.
Yeah, even though it's less than 30?
Mm-hmm. Because, like, the stuff that I read earlier and the stuff that I was just looking up, like, it wasn't super descriptive and it was kind of hard to understand, but it seemed like that's what it was saying.
That it was normal?
Yeah.
Okay. We can go with normal.
So, in taking samples of 100, what was the shape of the distribution of means histogram in the parent population is right skewed.
So that's a large sample.
Mm-hmm. Okay.
Okay, so important, regardless of the distribution of the population, if the sample size is large, the shape of the distribution of the sample mean is normal.
Okay.
Normal.
Would be normal.
Mm-hmm. Well, okay, so here's the thing. Oh.
Then wouldn't 3 be skewed right?
That's what I'm assuming because it's less than 30. And that's what it says. See, if it's not normal, the shape of the distribution of the mean is right skewed. Basically, it's less than 30. So when the sample size is less than 30, then the histogram is right skewed.
So 3 should be skewed right and 4 should be normal.
Yeah, that's how I'm understanding it.
Sample distribution. And using this sample distribution applet.
Where is that at?
Oh, it's from last week. You have to get it up from the thing. I have it up already. Let's see if I can.
That's the normal probability applet.
Oh. Oh, it's the. So if you look at the videos and stuff, the teacher uses this weird applet thingy, and he gives you a link for it. Or not in the videos, but it's in the lessons. Let me see if I can find it. Uh-oh. Hang on, guys.
normally distributed. I'm going to go with normal.
Sorry guys, just a minute. Okay, did y'all find that applet thingy?
Nope.
No. I will just go ahead. There's the applet right there. For time's sake.
Oh, that.
Uh-huh.
So out of the reading.
Uh-huh. Yeah, it is out of the reading.
Okay.
Yeah. Let me see. I have too many tabs open. Okay. So when n is 5, I need you to, well, I guess he's okay, just come in right now. But just be available. Okay, again. So the sample size is 5, I think. Let me do this. Okay, okay. What else does it say? What was the shape of the distribution means? Oh, it's a bell. It's normal. The shape. When it's bell shape, that's a normal shape. Because it's not skewed right and it's not skewed left.
So then technically wouldn't 3 be normal?
I guess so. But they can't all be normal. That's why I'm just kind of confused.
Well, we weren't told to use this applet for those questions. So, and it's for these, it's asking for the distribution of the means, not for the other one.
It's not asking for the distribution of the means.
For 5 it is.
The only thing that's different about them is it says when the parent so in like number 3 it says like what is the shape when the parent population is skewed right, and what is the shape of the distribution when the parent population is normally distributed.
Yeah. Okay.
So, but I'm not sure what that even means.
Yeah. I'm trying to think. Population's normal. It's going to create a bell curve. I have no idea.
I guess he wants to be part of the meeting too, guys.
I have no idea, you guys.
Hang on, I'm going back and looking. it says in the homework, like the preparation assignment for lesson 6, problem 8, it says if the distribution, like if that's normal, then you know it's normal when the parent population is normally distributed. So I'm guessing then for number 6, since it says that the parent population is normally distributed, my guess is so is the other thing.
So 5 is normal?
Yeah, I'm thinking so, because that's what it says in the homework.
Okay.
If the parent population is normal, then it's normally distributed. I could be wrong, but
Let's just go with it.
yeah. Like, I'd rather get every single problem wrong and be able to, like, figure it out than spend 3 hours and still get every single problem wrong.
Agreed.
Okay.
So when taking samples of when n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed?
I'm going to go with normal again.
Okay.
That's what I put.
When would the distribution of means be normally distributed? Let's stop screen. Data are drawn from the population that's normally distributed, and the sample size is small. Data are drawn from the population that's normally distributed, and the sample size is large. I think that's one of them.
Yeah.
Yeah.
Data are drawn from the population that's right skewed, and the sample size is small. I think that's one of them too, isn't it?
Population is small. Like, yeah, that kind of makes sense. Because the smaller the sample size, I feel like the more likely it is to be skewed.
Mm-hmm. And we agreed on 8. Was it the bottom one that we agreed on?
I put normal for both, I think.
No, for number 8. Which of the following gives the best explanation of central limit theorem? Because central, let's see, I have this written down. As the sample size n increases and becomes large, the distribution of sample means becomes approximately normal. So yeah, the very bottom one for 8 would be the answer on that one.
Okay, what did we decide for 7?
Oh, for 7?
The 2 middle.
The 2 middle ones.
Okay.
Okay, let x be a random variable with population mean equals 10, population standard deviation equals 6. Suppose a sample size of 36 is drawn from this population. What is the mean of the distribution of sample means?
So I think the formula, I think I wrote it down. I'm not sure if this is the right formula or not, but it's the little O thingy with it's like a cursive O over the pi, or the square root of n.
That's the equation for standard deviation.
Is it? Okay. Okay, so convert the value to mean. So you do the value minus the mean over the standard deviation. That's a z-score, isn't it?
Um, is, yeah, that's the z-score.
Okay.
I have the homework open, so I'm trying to find it. Okay.
You're a trooper, Sam, for doing the meeting and then all the other stuff that you got to do tonight.
Okay.
I don't know how to find the mean of the distribution of sample means.
Hang on. Okay.
What, Ronnie?
I don't know how to find the mean of the distribution of sample means.
Yeah, neither do I.
I feel like it only gives us the way to do the standard deviation of the sample mean.
Hang on, I just found a YouTube video that explains how.
You want to share it?
Let me see if it'll let me.
Isn't there a YouTube button on the side?
Hi, we're going to be talking about sample distribution.
Pause. Okay.
No, I live at Shoelon. This video. Alright. What if all that's saying is just find the mean of the sample means and the standard deviation of the sample means? Most of the time, you're going to be given what mu, population mean is, and sigma, population standard deviation. So you just have to find out what the mean of all those samples would be. Alright, so for example, we have the average weight of Mountain Lions is 91 pounds with a standard deviation of 28.0416 pounds. We know that weights of mountain lions are normally distributed. That's really important. Remember that you have to have a sample size greater than 30, or you have to know that our variable is normally distributed. Anyways, let's find the distribution of the sample mean of samples of size 6. Well, since we know that they're normally distributed, it doesn't matter that we have such a small sample. We know that mu of x bar, the mean of our sample mean, will equal the population mean. Population mean is 91, based on our information. Sigma of x bar is sigma over the square root of n. You need to take this step by step and round each number to 4 decimals in order to get the same number as what you're expected to know on your homework. So if we look at sigma, we know that that is 28.0416. We have to find the square root of n. Well, n is our sample size, 6. So we have to find the square root of 6. The square root of 6 is 2.4495, rounded to 4 decimal places. Now we take these two numbers and divide, and we see that our standard deviation of our sample means is 11.4479. And that is all there is to finding the distribution of the sample means.
So does that mean that the answer to number 9 is 10?
Did you calculate it out?
Yeah. I just calculated it out and I got 1, but it's just asking what the mean is. What's the mean? So it would be 10.
That's what I understood, is because in that video, that's what she did, is the mean of the distribution of sample means is 10.
Right.
And then number 10 would be 1.
Right. Wait, what is the standard deviation of the distribution?
Because to find the standard deviation, that's when you take the little o over the square root of n.
Right, and the square root of n was 36.
Yeah. So your answer to 10 would be 1.
Right.
So 9 is 10 and 10 is 1, correct?
Mm-hmm.
Yes.
Okay, regardless of the distribution of the population, if the sample size is larger than 30, what would the shape distribution of the shape mean?
Okay, so remember what I said on my notes earlier? Like, this is exactly what he was talking about. Hang on. It is, so, if the sample size is larger than 30, then it is normal. Yes, it is normal. And the theorem that would justify this would be the central limit theorem.
Okay.
Okay, so who wants to push submit?
I just did. Okay, so on 5, I had changed it to skewed right, and it is actually normal.
Yes.
Okay, on 3, it is skewed right.
That's what I put, yeah.
Okay.
Did you submit yours, Sam?
No, not yet. It's like loading, but I have like 30 tabs on my computer open right now, so it's taking like an hour to do everything.
We didn't do too bad.
On 7,
7.
did you already submit yours?
Yeah, I did. I'll just
Okay.
go in and do it.
Yeah, oh, you can redo it?
Yeah.
Oh, I had no idea.
We got 7 wrong.
Yeah, it's all the 3, but the middle one, like the third one down.
So we were wrong about the right skew of a small sample. It's the right skew of a large sample.
Mm-hmm.
Okay, that's what I thought.
So do you just basically like write down the answers and then go back and redo them?
Yeah, when you redo it, they're in the exact same order.
Oh.
We actually got 9 and 10 right?
Yeah.
I'm like half surprised about that, but not.
Well, I mean, because we watched the video. I mean,
Yeah.
that video thing kind of helped a lot. So I'm glad you found that on YouTube, Sam.
Yeah. Can I just say, when people actually explain things simplistically versus like 8 pages of jumbled crap, it makes so much sense. Because that's how I felt reading for this week was a ton of pages of jumbled crap.
I agree. So do you want to do lesson 7 group meeting homework?
Okay. I'm still writing down answers. Just a minute.
Okay.
Sam, are you good to do one more?
Yeah, I just need to try and do it fast if we can.
Yeah, let's do it fast.
Okay. Alright, going to the thingamabob.
True. Use the normal. Okay, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z1 point. Okay, hang on. So let me open my normal probability applet. Okay, so we have Okay, so what are we finding? Okay, use the normal probability applet to find the combined area under the standard normal curve. That is to the right of that and the left. So the middle area is what it's wanting.
So the area of that is 0.8255. So 0.83?
Round your answer to...
Oh, to the third decimal. So 826?
Yeah, 826.
Okay.
8255, so 826.
Okay.
Um,
You're doing really good, buddy.
okay.
The United States Coast Guard assumes the mean weight of passengers in the commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. The weight of the random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that the random sample of the passengers have a weight that is extreme or more extreme than was observed in this sample. So does this mean we need to use the normal probability applet, or is this like one of the formulas we were given?
I'm not sure.
I don't know either.
Okay. The distribution.
What's your dog growling at?
I don't know. She just growls at everything. There's nothing out there. I don't know what she's doing.
I say we skip it and come back.
Okay.
Okay. Which of the following will have a small standard deviation if 9 observations are randomly drawn from a population? The distribution of an individual observation, distribution of a sample mean. This cannot be determined from the information given. If 9 observations are randomly drawn from a population.
Okay. Cool.
I want to say the distribution of the sample mean.
That's what I want to say too.
What did you say?
The distribution of the sample means. Okay, which of the following results implies that the spread in whatever that is decreases as the sample size increases? It's not the 68, 95, 99 rule, I don't think.
Let me look at my notes here. I don't know why I keep pulling up this document. Yeah. Let me see. Okay, law of large numbers states that the sample size gets larger, the sample mean will get closer to the population mean. So it's not the law of large numbers. The central limit theorem says the distribution of sample mean is normal when X is normally distributed or when, thanks to our sample size, is large. So
I think it is the law of large numbers because you have your spread decreasing, so it is getting like closer.
okay.
But I don't know. Yeah.
Law of large numbers.
Okay. I'm gonna change this little guy real quick and I'll be right back.
Okay. Start the movie. It's totally fun. I've seen it like 1,000 times.
What?
Oh, talking to my roommate, sorry.
Oh.
Okay. I don't think it's the central limit theorem.
I don't think so either.
I don't know, because normal distribution creates that bell curve, so you think that your spread would decrease and your sample size would increase.
So is it the normal distribution then? Because that seems to make the most sense, because I don't see how it could be law of large numbers either.
Yeah.
And I don't see anywhere in here where it talks about the 68.
95-99 rule. And I don't think that really applies to it.
I wouldn't think so either.
So, okay. Scores on the quantitative.
So the normal.
Yeah, normal distribution is what I'm putting.
Okay, that's what I'm going to put.
Okay.
Scores on the quantitative portion of the GRE are approximately normally distributed with mean U equals 150.8 and standard deviation of 8.8. Use this information. Okay. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score?
Okay, so the Z-score was like the value minus the mean over the standard deviation.
Right. Okay, buddy. Okay.
So wouldn't it then be 160 minus 150.8 divided by 8.8?
I think so.
So 160 minus 150.8, and then divide that by 8.8 is 1.045.
$1.045, is that what you said?
Yeah, that's what I got.
Is that... I thought it had to be less than 1.
So do you think it needs to be switched, 150.8 minus 160?
But it's supposed to be the value minus the mean.
Yeah, it's value minus mean over the standard
Standard
deviation.
deviation.
But I thought, like, to put it... Maybe not. I don't know.
Because we've had Z-scores that were 1 point something. I think. I don't know. If we get it wrong, we get it wrong.
Yeah. Okay. So what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So...
This is the same equations we did last week. What is the probability that a randomly selected student will score a 160 on the quantitative portion? I don't remember the equation, but this was like the exact same questions from the homework from last week.
Well, wouldn't we use the same equation that we used for the previous problem?
No, we're finding the probability, not the z-score. So don't we take the z-score and put it in the normal probability applet?
Maybe.
And then, so if you did that, wouldn't you have the right side highlighted? So it would be 0.148.
What is the probability that a randomly selected student will score that? So it'd be anything from that and above. So 1480 is what I got.
So 0.148.
Yeah.
Wait. Oh, okay. I was just trying to figure out what y'all did, and I got the same thing. So.
Okay. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores?
So we have to find the mean first, right?
Yeah, the sample mean. So just add them all up and divide it by 5. I can do
Okay, so it's 160.
160. And then, so we have to just find the z-score for 160.
So what is our x?
Because there's 5 people, so so the value I want to say is 5, and then your mean is whatever that is, and then divided by deviation.
Which formula are y'all using?
The z-score formula, so isn't it value minus mean over standard?
Oh, okay. Okay, yeah.
I don't know what the value would be, though.
But isn't the value the same as the sample size?
5, but then you'd get 5 minus 160, which would be negative 155, and then we have to figure out what the standard deviation is. So
Well, we already have the standard deviation.
We do? Where?
Because we're using the same information from, like, question 7.
Oh, yeah.
We're using the same information through question 10. So the standard deviation is 8.8.
Okay, so
What y'all have?
Sorry, never mind. Go ahead. I'm not thinking the right thing. So
Let me make sure I have the right thing down. It's negative 155 over the square root of 8.8.
I get negative 17.613. I don't think that's correct. Okay.
what is the z-score corresponding to the sample mean of these students?
I'm trying to think.
I have a weird question.
Okay.
Shoot.
Can you use, because we just used the mean for the 5 samples, right? The 5 sample scores. So that would be our sample mean. Can we take our sample mean and then subtract the mean? So can we use the sample mean as the x?
Maybe. So 150.
Does that make sense?
8 minus 160.
Because it would be the same as question 7 if we could do that.
Then it would just be negative 1.04.
Why would it be negative?
I don't know. That's just what it brought up because I did the 150.8 minus 160 and then divided, which is negative 9.2, and then divided that by 8.8, and so you get the 1.045, but you get it negative.
Okay, because like the way you did that is you switched the x and the mean around, so it would still be positive because you would take x, which, if my assumption is correct, would be the 160 because that's our sample mean, so that'd be like our value, I would think. And then you subtract the mean, which is 150.8. I have no idea. I'm just wondering because I don't know what else you would use for x.
I don't know. You could just put 1.045, put the same answer, and then just see.
So 1.045.
Yeah, just do the same answer.
Why do the same answer?
Sorry, what?
Why do the same answer?
Because if we use the 160, which is the sample mean, as our x value, and then you subtract the mean, which is 150.8, and then divide it by the standard deviation, which is 8.8, then you get the same as question 7, which is 1.045.
Oh, okay.
But I don't know, like question 10 is, I don't know.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Is it trying to trick us? Because that would be the same as question 8.
I still think that question 9 is the negative 1.045. Because then your probability would be, for those 5 students, be everything above that, which would be 8520.
Okay.
I don't know if that's right. That's just what I think.
So 0.852?
Yeah, that's what the thing says, the normal probability applet.
Okay.
But yeah, I don't know. I don't really understand this.
Hopefully it gives us the answers.
Okay, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample equals 81 students will be drawn. Use the information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable which represents the sample mean of 85 students who are selected?
Would it be approximately normal? Because it's greater than 30?
Mm-hmm.
Yeah. Okay, what is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
If we're going off of that video we watched, wouldn't the mean of the distribution of the sample means be 3.5, which is the mean from the information?
I'm good with that.
Because that's what we did in the last one in that video, isn't it?
Yeah.
The mean is 3.5, and then what did you say your internet was breaking up?
That's basically it. Just that's what the video we watched said.
Oh, okay.
What is the standard deviation of the sample distribution of the random variable, the mean of 81 students who are selected? So that's just the bottom number used in that equation.
So the standard deviation would be 0.7. Right?
Or do you take the standard deviation and divide it by the square root of 81? To find the standard deviation of the sample means?
It's wanting the standard distribution for this of the sampling distribution. So I feel like you're finding that's really confusing. Oh. I don't know. Oh. I'll be right back, you guys. Feel free to continue. I'll be right back.
Do you have any ideas on question 13, Megan?
I'm just trying to figure out which formula to use if we do need. I think maybe we might be overthinking it. If it says the standard deviation and it gives us the answer 0.7.
So do you think it's just 0.07?
That's what I think. I mean, I think we might be overthinking it. But that's just me.
That's probably a good assumption.
Okay, I'm back. What did you guys figure out?
We're just saying that maybe we're overthinking 13, and it's just 0.7.
Okay. That makes sense, because that's kind of what we did last time, too. We overthought it, and then it ended up being, like, super easy.
Yeah.
Is it the same as the standard deviation or something?
Yeah.
You just do as theta.
Jared, just okay. 14. What's the probability that the mean GPA for 81 randomly selected BYU students will be less than 3.3? So the probability thing is that the little circle thing over the square root of the standard deviation?
No, that's not finding the probability. That's finding the standard deviation of sample mean.
Probability is using the applet.
The probability applet, how would you use that for this problem?
But you'd have to find the z-score first.
Which is value minus mean over standard deviation.
Wouldn't you take 3.3, so that's your value, and then subtract your mean, which is 3.5,
Uh-huh.
and divide it by your standard deviation, which is 0.07, right?
Yep, so it's negative 0.2857.
Jared, quit. Negative what?
0.2857.
And you want the negative side, right? So 0.387?
Yeah. What is the probability? I mean, 81 is greater than So it's going to be everything above that negative number. So it's going to be 612. Or 613 if you round it technically.
So 0.613. Okay. So who wants to oh wait. We didn't do question 4.
Wait, what was 14?
0.387.
0.387, and then the other one was 0.6 what?
13.
Okay, sorry, I had those two backwards.
Commercial boats and 185 pounds. As extreme or more extreme means that we are not only interested in values that are lower than those reserved.
So are we just trying to find the probability of their weight being greater than 185 pounds?
Yeah.
Sounds like it.
So we just need to find the z-score then. So it would be hang on, it's going to be 185 minus 177.6 divided by 26.7, and then so 0.277. Okay, and then are we trying to find everything below or above?
It says as extreme or more extreme. So I would think above.
Above, yeah.
Extreme or more extreme. Okay, so that's 3909. So 391.
So
And then submit.
Okay, we got 3 and 4 wrong.
Your computer loads so fast. Holy heavens.
It's new. It's a new computer.
oh, we got an F. Six is wrong. It was the law of large numbers.
What? I'm sorry, you broke up.
Number 6 is wrong. It's the law of large numbers. We got 9 and 10 wrong. And we got 14 and 15 wrong.
My computer is still loading. This is ridiculous. It's probably because I have like 12 history apps open right now about amendments for this stupid paper I have to write.
Ouch.
Ugh, yes. So it says we got 14 and 15 wrong, you said?
Yeah.
Did it say how? Like, does it give us an equation or anything?
It says you're supposed to do z equals the x minus, so x minus the mean divided by standard deviation divided by n, square root of n. So you're supposed to take 3.3 minus 3.5 and then divide that by 0.07 divided by the square root of 81, which equals negative 2.5714, which then corresponds to 0.0053. probability. That's a lot of. It should give you answers in.
Is it giving you guys the correct answers?
Mm-hmm. Is it not giving you the correct answers?
Mine's just still taking its sweet freaking time.
I know it's annoying to you, but from our end, it's kind of funny.
Okay. Okay, mine finally loaded. It's not giving me the correct answers in mine.
Okay, so 14 looks like it should be 0.005. Looks like 15.
0.9949 is what I have.
Yeah, so 0.995. 9 and 10, it just tells us how to do it. I'm not sure on those ones.
Didn't we try to find the z-score for 9 and 10?
Yeah.
Did you guys get 13 wrong?
No?
Yeah. Wait. Yeah. Did you get 13 wrong?
No,
Yeah.
I'm right. What'd you guys put?
I put 0.7.
It's supposed to be 0.07.
Yeah, it's 0.07.
Oh!
I don't know how I got that, but
So 14's 005, 15 is 9949.
yeah, so 0.995. So number 9, we were supposed to do. We were supposed to do the same formula that we did for question 14. So,
Let's look out. Sorry, did I miss anything?
no.
Okay.
So it says for 10, this is the area to the right of the 2.3377 in the normal probability applet.
Yeah.
So if I put that into the applet, the area to the right is 0.0097.
So 10 is that the answer for 10 is 0.00. So it'd be
Your answer to 4 decimal places, so 0097.
Oh.
Okay, for 10 you said it was 0.0097?
Yes.
And for 9, what did you say it was?
So wouldn't 9 be 2.3377? Sam?
I'm trying to. I'm looking at it.
Because 9 and 10 go together, right?
Mhm.
Yeah, so this is the area to the right of, well, that's the z-score is the 2.3377.
Yeah, so that's what we were trying to find in number 9, so I would think it'd be the 2.338.
Yeah. Okay.
And then 3 and 4 we got wrong, and it doesn't give us any help. I think I know what we did.
What is it?
1.358. Because we did what was in the center, and you're supposed to find what's on the right of the positive one and what's on the left of the negative one. So you're looking at the two tail ends, and we looked at the center, right? That's how we did it.
I think
Mhm.
so.
So then, if that's the case, then the answer to that one would be 0.175.
Okay, that's for 4,
3.
for 3, and what was it?
0.175.
Sorry, what?
0.175.
5. Okay, thank you. Sorry. Computer kept breaking up. Okay, so then for 4, we're just trying to find the probability.
And I thought we did that one right.
That's what I thought too.
I'm wondering if it says since it's as extreme or more extreme, if it would be the middle section and above the line, and that's what we did wrong.
Oh, well, it says either above or below the mean. So maybe that is what we did wrong.
What does it say, Sam? If that's the case.
I don't know. I don't remember what the number was for the z-score.
We got, for the z-score, it was 0.277.
Mhm.
And we just did above, so if it was,
It would be middle and above, wouldn't it?
yeah, it would be the middle and above, so that would be 0.609.
Okay. And that's for 4, so, okay.
So hopefully that's the case, and we did it right. We just didn't choose the right sections on the applet.
Mhm.
Is it allowing you to redo it?
No, it usually
Not
takes a
yet.
while before I'm allowed to retake them.
Yeah. Okay. So why don't we try meeting up again on? We actually have to have the homework done by Thursday in order to retake it. So we can't just do it on Friday and Saturday. So would y'all like to meet up again tomorrow?
I'm pretty sure you can redo it until Saturday, or you have until Friday night to retake or do your homework to be able to do the retakes.
Really? Okay.
That's how it's been since the beginning of this semester anyway, so.
Yeah.
Okay. Well, do you want to go ahead and close this meeting?
Yeah.
Okay. Sam, I hope you get to feeling better.
Thanks.
Yeah, get better.
All right. Good meeting, guys.
So, how do we post our link really quick to the...
I'm going to post it. I'm just going to go ahead and go post it now. I'm going to hit stop broadcast, and it'll give me a URL. And
Okay.
I'll just post that URL, and there's our meeting.
Sounds good.
I
Okay.
put the info from last meeting in the thing.
Okay. Terrific. Thank you.
Yeah, no worries.
All right.
Okay.
See you later.
Next week.
Bye. Thanks.
Bye.
Bye.